right, have you guys all got your notes there right now?
Hey.
Everybody have them? So yesterday, guys, we were looking at slope-intercept form, and which variable were we really concerned about having alone yesterday? Wanted y alone, okay? And then that number that was right next to x, like a 5x or a 2/3 x, what did that represent again?
Slope.
And then what did the b value on here represent?
Yeah, y-intercept.
Y-intercept. And we said if we were going to graph anything like this, we said the first thing you would do is plot the y-intercept, and then from that, do your slope from that point to get another point, and then you would have your function defined, and then you could use that to make any point locations that you might need for that function. So, guys, of A and B, which one of those two is in slope-intercept form? A is. What did we have to get alone here? So basically, we used our rules of function form on part B in section 8.2. Just a quick review. Ask ourselves, is y positive in this right here? The answer is
Yes.
do I need to change anything?
No.
So what we did is we moved the x to the other side, in which case this became 3y equals, if 4x is positive on the left side, it should be what kind of 4x on the right side?
Negative.
You guys agree with that? And then you divided everything by 3. Yep. So in this case, this allows me to put this in slope-intercept form, and we ended up with negative 4 over 3x plus 3 yesterday, right, kiddos? And once I got that down into function form, we said, hey, what's the slope? And we identified the slope as what value up there?
Negative 4 over 3.
Negative 4 over 3 would be the slope of that function. And how about the y-intercept? Where are you starting? What's the initial value? 3. Okay? So again, we said when we're doing these, you need to have y be alone. Okay? Y is alone. All right? And we talked about y having a split personality yesterday, right? And I believe Courtney gave me a hand for that joke yesterday.
No, I'm the one who did it.
Slow clap.
Slow clap. That's impressive. I got a slow clap. Courtney. Who knew? I'll reciprocate.
Oh my God. You say that word.
All right, let's rock and roll. We started yesterday. I believe we ended up right here yesterday, right?
Yes.
We talked about graphing this yesterday. What was the y-intercept that we started with in this graph yesterday, kids?
2.
Positive 2. So we said start on the y-axis at 2. All right, and then from that point, slope. Do your slope. A rise of negative 3 and a run of what? 4. That rise of negative 3, does that mean move up the y-axis 3 units or down the y-axis 3 units?
Down.
And then to the right, how many?
4.
Okay, just to make sure I'm okay with this, I've gone down 3 and right 4 from the y-intercept. Guys, does it appear that that graph is going to show linear growth or linear decay? Or be uphill or downhill, if you will? Downhill. And downhill lines, we talked about having negative slope, right? Do you have negative slope in this example right here? Thanks. So does this look like this could be a possibility for the graph of y equals negative 3/4 x plus 2? It does, doesn't it? Okay. And then from there you draw your line. All right. Okay, guys, so here's what we need to get into today. One thing you're going to want to do, make sure you have your Chromebooks out. So why don't you take a minute and do that. And guess where I'm telling you to go again today? Yes. How many of you guys use that tool to help out? Are you guys using that often? I think it's a great tool. It's a great tool for checking stuff, isn't it?
I had to get me a Chromebook yesterday.
Oh no, what happened to yours?
My mouse pad's broken.
I still have to pay for mine. Same.
Why do you have to pay for it? What did you do?
Because, like, okay, so after the weekend, like 2 weeks ago, I came to school Monday and I opened it up during third hour and the screen was just cracked, even though I didn't use it all weekend.
Yeah.
Someone stepped on it or you left it out in the cold.
No, it was in my bag in my room and I didn't even touch it all weekend. And it
Did you like touch your bag once you got home, or did you like put too many stuff on top of it? Like math books can definitely do that if you touch it.
Well, they are built by the Ford company, you know that.
Really?
And the quality's not very good.
That's
You
why
guys
they
are-
all break.
You guys fail. I've had this all
year.
year, not a single scratch.
Actually,
dent.
you haven't had it all year because we didn't get it.
Well,
until
not
second
all
try.
year. You know what I mean.
Yeah.
All right, Desmos is where you need to be. Make sure you get there, all right?
My brother broke mine. He tried shoving me in the snow and I tried to run the sled. I want to play Crash and right now. I like that game. Show me again.
I don't remember.
I don't even know. I can't even download
I have a
apps on
game,
it.
and I really used to. I like to play it, but now I forget how to do it.
All right, kids.
It doesn't look like how to play.
And it times you. It makes it pressure.
Pressuring.
Well, those are how to play.
Yeah, that's pressure.
Guys, what I want to start on through here today is to talk about this idea of parallel and perpendicular lines. And I think the first thing we need to understand is the definition of parallel and perpendicular lines. I told you the old joke yesterday about parallel lines, right? Parallel lines. They have so much in common, it's a shame they will never meet.
Ha!
You get it?
Wait, what? Say it again.
Parallel lines have so much in common, Maddie. It's a shame that they're never going to meet.
Oh, I get it.
So what are parallel lines then, if you get the joke?
They're lines that are never ending next to each other.
Okay,
They don't
they're never
ever
ending,
cross.
and they'll never ever cross. And they'll get closer to each other, but they never grow any further apart. Okay? So, in the real world, or maybe an example in this room, where is there an example of parallel lines in this room?
Lines?
The brick lines, horizontal brick lines right here. This line extended all the way in this direction, and this line all the way extended in this direction. Will they ever cross?
No.
Are they getting further apart?
No.
Parallel. So we understand what parallel lines are, right? I have a question, guys. What kind of a line am I kind of drawing out here on the brick line up here?
A straight one.
It's straight. Talk about in terms of vertical and horizontal.
That's horizontal.
That's horizontal. What's the slope of a horizontal line? Is it 0 or undefined?
Undefined. No, 0.
It is 0, right? This line is also parallel to it. It is horizontal. What's the slope of this line?
0.
Oh my gosh. What's true about the slopes of those two horizontal lines I was trying to walk back and forth on those bricks? They're both 0. Slopes are the same. Slopes are the same. So when we start talking about slopes of parallel and perpendicular lines, let's talk about parallel lines first. We just found out up here, two horizontal lines that are parallel to each other on the wall both have the same slope. So if two lines have the same slope, if they have the same slope, what kind of lines do you have? Okay, so I will say parallel lines have the same slope. Now today I want to grab a ruler. To do this, I'm going to put an example down here of parallel lines. Let's do this. Let's go. Why don't you guys write these two equations down that I've put in slope-intercept form up here. Y equals half x minus 2, y equals half x plus 3. We're going to look at graphing these. Let me know when you've got A, a ruler, and B, the example written down that I have in this section of the notes.
Why do you have 2 coffee cups?
This is for water.
I like the flower.
I love it, isn't it? Just, it's nice and green, nice green grass, the flowers are growing. A little bit of spring in the air. So look out your right eye.
My right eye is not as strong as
Where you
I haven't
want-
taken my contacts
I
out in like
can't
3
try.
weeks,
My nose is breaking on spot.
That's not good, Maddie.
I have to drive 3 hours. I'm fine. I'm gonna like kill us.
Don't drive 3rd hour.
Just tell
I
her.
have to.
Just tell her that, or whoever you drive with,
Special one.
that you can't drive
Mhm.
because your contacts.
Have you guys got these examples written down right over here? Example 1, example 2?
Yes.
Let's talk about graphing these right here. I want to go ahead and explore. So first of all, are both of those equations in slope-intercept form or not?
Yes.
They're in good shape here. What's the slope value on the first equation up here?
1/2.
1/2. What's the slope value on the second equation right here?
1/2.
We just got done saying that, hey, you know what? If the slopes are the same, we believe that those two lines are going to be what kind of lines? Parallel, right? Okay, so let's do this quickly. Let's go ahead and graph this first example, half x minus 2. Kids, help me out. What's the y-intercept going to be in the first example?
2.
What kind of 2?
Negative.
So where do you want to start, Karen? Say again, I didn't hear you. Yeah, from the origin, so am I going to move up 2 or down 2 to start? Down 2. Negative 2 is the y-intercept, all right? And then through that point, guys, what's my slope?
A half.
So from this point, I'm going to rise 1 and run 2, and that puts me about here, doesn't it? I'm going to do this for a little bit. Keep rising 1, run 2 on your graph. And then you can also come back down 1 and back to the left 2 like this. Down 1, left 2. Gosh, this graph paper is terrible. Okay, those are some pretty good points for that first graph, y equals half x minus 2. So I'm going to go ahead and draw this line quickly.
Wait, what did you say from the one that we already made you do?
The one that we had here, I just kept going up 1 and over 2, so my line's really good shape. And when I run out of room over here on the right side, Darren, I came back to my y-intercept right here. I said, you know what, to continue the line going this way, I could come down 1 and back 2. Down 1 and back 2 to stay in alignment. That make sense to you? Okay, so I'm going to draw this line right here quickly. Whoops, try to anyway. Try it again. There we go. That's a good one. So this is the equation y equals 1 half x minus 2. Okay, y equals 1 half x minus 2. Everybody follow that with me? And again, I could jump into decimals to confirm this, right? All right, so let's take a look at the graph of the second line. Let's look at the second line. How about the graph of the second line, guys? Where are you starting at in the second equation?
Positive.
Positive 3. So from the origin, go up how many units?
3.
3 units. And then how about my slope to that point?
Minus 1.
So I'm going to do this often. Rise 1, run 2. Boom. Rise 1, run 2. Boom. Rise 1, run 2. Boom. I'm going to back up. Down 1, left 2. And I'm going to stay in alignment so I get a really good line here. I want to really see what's actually going on here. Okay, so those are all the points that I've plotted. So I'm going to come back to my tool to draw a line. You have a straight edge out there, kids. Ooh, let's make a line green line. What the heck? It's going to be a Christmassy line. Yeah, that's right. Is this equation right here? Looks like we have y equals 1 half x plus 3. I'm going to circle the 2 1/2s right here. Okay. What's true about the slope values again? Are they the same or are they different? Turned out to be the same this time, didn't they? So when they're the same like this, I'm getting at is this. If you have two equations in slope-intercept form, or you rewrite something so that you get the slope-intercept form, and you find out that those slopes are the same, what type of lines are you going to have here? And parallel lines. What's the joke? The joke is, it's a shame that parallel lines, well, I'm sorry, I screwed it up. Parallel lines have so much in common, it's a shame that they will never meet. Oh, come on. No applause? Jeez.
No, you got applause the first time.
I was waiting for you to throw tomatoes at me. All right. Okay.
We don't have any.
I'll throw math book.
I've had kids throw
It's
math
like
books at me
Facebook.
before,
You know,
Courtney. You know
it's
what?
easy.
You know what? I throw them back, and I never miss.
You wanna know
You
something
got one
Mr.
good eye.
Parsons?
You don't want two bad ones. Watch it.
You wanna know something, Mr. Parsons? Clapping is like Facebook. It only feeds your ego.
What do you mean?
What?
I like to clap for a job well done. What do you mean? Feed your
I'm
ego.
so confused.
You know,
This makes
ego,
no sense.
ego.
Do you have Facebook?
Nope.
Okay. All right.
I don't really
Feed
use
your ego.
mine.
Make
What
you train off.
is
Terrible.
the big idea here? What's the big idea in this example?
Larson.
Other than I have a big ego.
Parallel lines.
Parallel lines. What's true about parallel lines?
They'll never meet.
They'll never meet. But when I look at this right here, what What characteristic of slope-intercept form are we looking at to say, hey, instead of even graphing these, I know these lines are going to be parallel. How would I know if they're parallel without even graphing? You're looking at the slope values, and you're asking yourself, are the slopes the same? Very good.
That didn't work.
Okay. All right, let's look at the next page then.
The next page.
Next page says this. Okay. Next page says this. This is where things get kind of tricky. Perpendicular lines. This is what I want to talk about perpendicular lines with you about. Perpendicular lines. Okay.
Perpendicular.
Courtney, I'm going to apologize to you in advance, so don't chew my
Say
head off today.
reciprocal, I'm gonna leave.
I have to today. It's part of the rules.
Just say blank.
Nope.
Wait, why can't you say reciprocal?
I don't know. She doesn't like that
What
word.
did you just say?
Okay.
Reciprocal.
All right. Hi, Lyd.
Hello.
All right. Here's the characteristic about perpendicular lines. First of all, what does it mean to be perpendicular? Anybody idea?
You're purple, obviously.
What if I told you that the floor and the wall, if the carpenter built the stool correctly, are perpendicular to each other? The floor and the wall, perpendicular to each other.
They're opposite.
Well, they're kind of opposite. Here's the wall, right up front. Here's the floor, right down at the bottom.
Wait,
They're like this.
Yeah, and so what? Do that again, Maddie. Look at Maddie. It's like this,
I don't know.
and like that.
Whatever.
Okay. So
90 degrees.
what's the what?
Oh, 90 degrees?
90 degrees. Yeah. The assumption is there's a right angle for it, right? Okay. If this is built correctly, wouldn't you guys? We always talk about stuff being square. Well, squares have what kind of an angle in them? Right angle measuring how much, Darren? 90 degrees. So the idea of perpendicular lines is this. Perpendicular lines are 90 degrees apart. Perpendicular lines love each other. You know why? Because they get on this long path of a destination, and eventually their paths are going to meet, and they fall in love at a certain point. Okay, I guess that was corny too.
Wait, what did you say?
Anyway!
You don't even get a slow class for that one.
Alright.
Wait, I don't even know what you said.
You know what? I hope you poke your eye out.
Alright, thanks.
Here we
I
go.
can see better without my contact.
Here's the rule. Here's the rule. If lines are perpendicular, here's the rule that you need to write down. This is very important. Slopes are the opposite reciprocal of each other. Now, guys, I know that the opposite reciprocal is considering a finishing move for me when I'm actually the square root of pain on Monday nights. Opposite reciprocal is my finishing move in the WWE. You guys don't believe me, do you?
No.
Square root of pain. That's my name. My finishing move's the what? It's called the opposite reciprocal.
Oh, I wasn't paying attention.
Opposite reciprocal. I'm going to prove this to you real quickly. I want you to do this. Go into decimals real quickly, okay? I should back up. Did you guys have that down?
No.
Let me know when you've got that down. Slopes are the what?
Opposite reciprocal.
Opposite reciprocal.
Stop saying that word.
Yeah, you shouldn't put so much emphasis on opposite like that. It makes me mad.
Opposite reciprocal.
No. I hate that word. Why? It's just
Do you like the word
a word.
precipitation?
Precipitation.
Not really. Not
Well, you
now
have to
that
learn
you
about
said
it next year in science. So.
Not now that you said it.
You just don't like anything I say, do you?
Probably not.
You're a fun hater.
Okay.
Alright.
Nice talk, person.
Yeah. Slopes are the what of each other?
Opposite reciprocal.
Okay, first of all, what's the word opposite mean in terms of math? If I have a positive number, then an opposite would be a negative. Okay? What's reciprocal mean? Like if I had a fraction 2/3, what's the reciprocal of 2/3? What do you do with the numerator and denominator when you reciprocate stuff? You flip. You switch the numerator and denominator. Okay? So it sounds like to me we have to take a fraction and do what? Flip it, and then change a negative to a positive or a positive to a negative. So there's two changes actually going on here. Change the sign, and then flip the numerator denominator. Okay, so here's a question. I have a fraction 2/5. 2/5, positive 2/5. What's the opposite reciprocal?
Negative
5
5.
over 2. Make sense? We had a positive, so we had to make it a what? And then 2/5 became what? 5 over 2. You okay with that? let's do this quickly. Jump into decimals. Type this in quickly. Type in y equals, and I'll do the same thing up here. Type in y equals, oh, let's just go, Mrs. Miller, give me an equation in slope-intercept form.
You want a fraction?
Sure, why not?
Okay.
Or whole number. Talk about a whole number.
Let's do 4x minus
4x minus 3. All right, so real quickly, kids,
It must be a 9.
check this out. This is pretty cool. This is a nice little graph. 4x minus 3. Looks like the y-intercept is what value right down here?
Right there.
Okay, and does it look like if I go up 4 and over 1? Okay, now, here's the deal. Mrs. Miller gave us an example of slope-intercept form. What's the slope up here in this example?
What? Oh.
Slope is 4. You guys agree with that?
No.
Slope is 4, right? Okay. What does 4 look like as a fraction? 4 over 1. Okay. Now we're not talking about parallel lines. We're not talking about the same slope. We're going to start talking about perpendicular lines. Lines that cross to form what angle? Perpendicular. How many degrees? 90 degrees. What's another name for a 90-degree angle? Not left, but right angle, right? Okay. We just got done saying we want the opposite reciprocal of lines. To prove this, we're going to look at this. What would the opposite reciprocal of a positive 4 be?
1 over 1/4.
Positive 1/4 or negative 1/4?
Negative.
Have to be negative 1/4. So what I'm going to do is this. I'm going to come down here to number 2. You do this and watch. I've got y equals, what's a, oh, let's go negative 1 over 4. Whoops, didn't want that. I don't think you guys want to talk about hyperbolas today. Or ever, for that matter. Although Lydia Lorenza could explain everything about hyperbolas to you today if you wanted her to. Right, Lyd?
Yep.
Let's change that back to a 3 or a 2 so I have some room to work. Guys, look at this right here. What was the slope in this line right here, the red?
4.
What's the slope in the blue line? Negative 1/4. We would say that 4 and negative 1/4 are blank blank of each other. What's the 2-word phrase?
Opposite reciprocal.
Opposite reciprocal of each other. Okay? Now watch what I'm going to choose to do here. We said that if you have slopes that are these the opposite reciprocal of each other? 4
Yes.
and negative 1/4? They say they're perpendicular, or the two lines cross in such a way that they form a 90-degree angle, correct? Watch this real quickly. This is so neat. I love doing this. Actually, it's really the first time I've done it like this. Mrs. Miller, you're going to get a kick out of this, okay?
Okay.
Wait,
Hey Lydia, do you have gym today? Have fun with the National Guard today.
yeah, I heard. Not too worried.
Mine's been like,
Yeah, I know.
mine's been
Well, like I fall asleep with them in the morning and I'm gonna take them out.
yeah, see, mine's
You can order ones that you fall asleep in.
Yeah, no, but like my
You're
eye
not
doctor's
really
like, if you
supposed
fall
to.
asleep with him, that's fine, but
Yeah.
like, he doesn't like
Here, I'll
it.
just take them out now.
They make them like that though. Too.
What?
They make them so you can sleep.
Yeah, that
Yeah,
one
but
was
you're
hard
not
to get out because it was like stuck to my eye.
Yeah, that's the only thing I don't like about sleeping.
Hey.
Oh, I just go to bed, I don't even.
I don't even care. I just like leave it. My mom always gets mad. She's like, "You're gonna go blind."
Actually, you could.
You can, but oh wait, one time I thought my contact fell out. And really, it was behind my eyeball. Like it was under my eyelid and like shoved back.
That's how it happens to my
And
head.
it took forever to get it out.
What is that?
Lydia, will you do me a favor and hit the delete key just one time, or backspace? Did that work?
Okay, if this doesn't work, we'll just go put in something.
Oh no, there you
There we go. Okay. Hey, check this out. This is so cool. This is called a protractor. You guys know that, right? Measure angles with this thing, right? I measure this angle. These two lines that intersect. Do the best I can.
Oh, that's 91. There we go.
Pretty darn cool, mister.
Holy cow. what's it say that these two lines right here, when you put your protractor up here, what's it say about your angle?
90 degrees.
90 degrees. 90 degrees meaning a right angle. Right angle, the word we use for right angle, or lines that intersect to form a 90-degree angle, is called perpendicular. You get perpendicular lines when the slopes are what kind of slopes of each other again? Opposite reciprocal. So let's understand this. If you have two lines and the slopes are the same, what kind of lines? Parallel. If you have one slope and another slope that's its opposite reciprocal, what kind of lines do we call that? Perpendicular. Okay? You guys buying this?
Yes.
All right. So, you guys agree with my argument after I measured this out, right? Everybody okay with that? So let's do this. Let's do this. Let's jump back into let's jump into this right here. Example 3. I love example 3. This is a really important one. I think if you can understand example 3, you'll be in really good shape. It says finding slopes of parallel and perpendicular lines. I'm going to put a little note up here and say, you know what? Don't forget. Need y to be what? Alone. You need y to be alone. Let's do this. It says find the slope of a line that passes through the given relationship to the line 5x plus 2y is 10. First things first. This line right up here, is this line good? Is this line good or is this line bad?
There's no line.
Now let me get there. Hang on one second, Mr. Kellen. Is that good or is that bad?
That's bad.
That bad. That bad. That really bad. We need to get y alone. Here come the questions. Let's go to function form. Is y positive or negative? Move the...
X to the other side.
So I'm going to have 2y equals, what kind of x on the other side now?
Negative.
Negative 5x. You guys are on a roll. Plus what?
2.
Plus 10. Next step, divide everything by what?
2.
If I divide by 2 here, what do I have?
Cancel each other out.
They're gone. So you're going to end up here with y equals, let's see, does 2 go evenly into negative 5? Then leave it as a fraction. Negative 5 over what?
2.
Negative 5 over 2. And then if I divide the 10 by the 2, what are you going to have?
5.
Okay, first things first, guys. Oh, you know what? I forgot something in there. What did I forget?
X.
I forgot the x. I'm human. I'm human.
Are you really?
First mistake I've made all year.
You're only human.
Yeah, that's only like the 5th time you said that.
It's a good thing I'm over 40. I forget every time what I say, so I still think I'm perfect.
That's like Christina.
I've already forgotten what I just said. What did I just say?
I'm not
You
perfect.
said you're going to have
I'm not
jelly ranchers at the end of class.
I'm human.
Something, something, something.
Something, little something, something,
Something
something.
about jelly ranchers at the end of class.
Okay.
Really? In the 4th dimension?
What's the 4th dimension?
Time.
I get that reference.
Time is the 4th dimension.
What's it for?
I get that
I thought it was
reference.
smell.
What's the dimension?
No. Dimensions give you the, okay, so you have a length, a width, and then a depth.
I
It gives you like a
definitely- I'm the
three-dimensional
only
thing.
Oh.
I'm
The
the
4th
only one that
dimension
got
is
that.
time, moving that thing through something, and it takes
Alright.
time to move that thing through the 4th. So time's the 4th dimension.
What's the 5th?
I don't know. It's a movie. The 5th dimension's called a movie, isn't it? Or is that the 5th element? I don't know.
Yeah, it's 5th
Doesn't
element.
Can I identify a slope in this line?
Yes.
What is it?
5.
Negative 5 or 2. So the question becomes, guys, if I had another line, and you want that line to be parallel, what would the slope have to be parallel to this?
Negative
5
5.
over what? Negative 5 over 2 is the slope you would need to have as a parallel line to this. I want to do this. I'm going to go back to Desmos. Watch this. This is so cool. Somebody please read to me what the original equation was that I circled up in standard form, please.
2x.
Hold on one second. I've got to get my keyboard. 2x plus, I'm sorry, Mason, go ahead.
Okay, 5x.
I'm sorry,
5x.
5x. Okay,
5x
5x
plus 2y
plus 2y
equals 10.
equals 10. Okay, there's the line right there. We all agree? You guys kind of agree with that? Okay, we just got done saying, you know what? I can make a line parallel to that existing equation that's graphed out there if I have a slope of what value? What did you write down there for parallel slope?
Negative 5 over 2.
Mrs. Miller, give me an equation in slope-intercept form where that slope is negative 5 over 2.
Okay, y equals negative 5 half x, or 5 over 2x.
Okay?
Let's do plus,
Not 5.
yeah, not 5, plus, 2.
Arjun, why are you doing this for?
I don't know. Finding out that I'm not very flexible. What'd you think? What'd you think?
They're parallel.
Parallel. Do we have the right slope? Do we know we have the right slope? Okay. So we're good there. So let's jump back here. If the parallel slope is negative 5 over 2, in other words, the same slope, then what would the perpendicular slope have to be? Opposite reciprocal, it would be what?
2 over 5.
Yep. The negative is going to become a
Positive.
positive. Numerator, denominator, switch. So perpendicular slope to that line would be 2 over what?
5.
So let's write an equation in slope-intercept form with a slope of what value?
2 over 5.
Oh, this is so much fun. I get kind of excited about this section, Mrs. Miller. I've got to apologize. Y equals 2/5 x. Somebody give me an intercept. Plus what?
5.
Boom. Oh my gosh. Does it look like these are 90 degrees apart again?
Yes.
You understand this idea of, okay, that first function, I put it into slope-intercept form. We said, hey, that slope, negative 5 over 2. Okay? So what's the parallel slope have to be? Well, I wrote an equation in slope-intercept form with the same slope, negative 5 over 2. This purple line, how does it relate to the green line?
Parallel.
Parallel. Then we said, you know what? What would a perpendicular slope look like? Turn this negative to a
2.
positive. Numerator, denominator,
Flip.
flip. What's your slope?
2/5.
2/5. Looks to me like when I had a 2/5 line right here. Oh. Looks like a how many degree angle there?
90.
Makes sense to you?
Yeah.
Let's have you guys try a couple on your own, okay? What I would like you guys to do is this. Down below here, on your own. Is the first equation nice to work with or not nice? It's real nice to work with, right? I want the parallel slope and the perpendicular slope to that line. By the way, what's the slope of this line already?
Negative 5.
-5, which is the same as -5 over what?
1.
1. You should be able just to spit the perpendicular and parallel slope out easily for this one. Are you going to have to manipulate this one, or are you going to leave it the way it is?
You're gonna have to manipulate it.
Okay, get this in slope-intercept form. Figure out what the slope is. Give me a parallel and perpendicular slope. I'll give you 2 minutes. Go. If you get stuck, talk with your neighbors, okay? You're fine with it. I just need to put attendance in quick.
That's okay. I just wanted to give you a quick update.
Okay. Give me about 5 more minutes, all right?
That's fine.
Cole Pearson in school suspension. I wish I knew why. Is everybody here today then? Are we missing anyone?
Christian's going.
Oh, okay. What's that, Maddie?
I said JK, Christian's gone.
So Christian's the only one missing, right? Okay. Remember, in the second equation, what do you have to get alone before you can proceed?
Why?
Okay,
Why?
because I said so. Oh, last page is a quick quiz. We're almost done, kids. Here, find me a good looking Nike polo in here and get one page that I could put some embroidery on for track.
So we're
Coaching.
coming up to that.
Track and stuff,
Okay.
30 more seconds.
Oh, he's a guy.
Why do you have such big fingers?
Alex has huge hands too.
You wanna arm wrestle? I almost beat
I
my
don't
dad
arm
last
wrestle.
night.
I don't arm wrestle. I'm always afraid that my thumb will get hurt in an arm wrestling match because I'm the undefeated thumb wrestling champion of the world.
Not more.
What?
I almost beat my dad at a arm wrestling thing. But then my wrist started to hurt, so I'm just like,
Couldn't have
whatever.
been dumb. You're laughing at it.
That's why she's laughing.
Oh, really? All right, gang. Let's talk about this first one, guys. I need to find a parallel slope. I always like to sometimes put these symbols like this, It looks like an 11. Those two lines are what kind of lines? And then I like to put an upside down T sometimes.
Why?
That means
Oh.
perpendicular slope. Okay. Okay, first of all, can you identify the slope in the first equation without manipulating it? Yes or no?
Yes.
It's already in slope-intercept form. So what's the original slope, gang?
-5.
-5. So what's the parallel slope to that line going to be? Same thing, -5, right? All right, but guys, -5 is the same as -5 over 1, isn't it?
Yes.
So how about a perpendicular slope for that then?
1/5.
Positive 1 over 5. You guys agree with that? Okay, positive 1 over 5. We all agree there? Good. Okay, now the next one. Do I have to change it or can we work with it?
We have to work with
We'll
that.
work with that, don't we? Okay, first question I'm going to ask, we've got to get the function form. So I want y to be positive. Is y positive? The answer is what?
No.
No, wait. What are you doing with all the signs?
Change.
Help me with the rewrite then.
Oh, okay. So you would take 2x.
Well, we've got to change this to a positive 3y first, right?
Yeah.
That's what I want. We said if I change one sign, you have to change
Others.
all signs. So help me with the rewrite, kiddos.
So the -3 will turn to a +3.
So what about the 2x though first?
-2x.
Plus 3y equals what?
-6.
Guys agree?
Oh.
You guys agree?
No.
Next one. Move the -2x to the
Other side.
other side. Aerosmith sang a song that said, "Take me to the other side." Well, okay, then never mind. Too old for you.
Wait, what song was that?
Take me to the other side.
Wait, what?
Why don't you take me? Take me to the other side. Okay.
I feel like I grew
Mrs. Miller, do you know it?
I'm not sure.
Not sure.
Man made up.
Probably not your genre, is it?
FFA members, please go to the odd at this time for group picture. FFA members, please go to the odd at this time for a group picture.
What are you dividing everything by? 3. Boom. When I divide by 3, divide by 3, divide by 3. Help me out, kids. Y equals, hey, is 3 going to go into 2 evenly?
No.
Leave it as a what then?
Fraction.
What's 6 divided by 3 going to get you?
3.
Ah!
-3.
Ah!
Ah!
Positive.
2.
3 over 1.
Ah!
6 divided by 3?
2.
Okay.
Oh, you started saying 3, so I just
Scaring me. Parallel slope equals what?
Oh my god.
From this slope-intercept form. What's the parallel slope going to be, kids?
2/3.
2/3. Good. Are you guys okay with what this symbol means right here that I just put up here on the board?
Yeah.
How about my perpendicular slope?
Yeah, I guess.
Okay, let me back up. Do you understand after I get into slope-intercept form right here, this is slope-intercept form. What was the slope of the line after I manipulated this to slope-intercept form? The original line slope is what? 2/3. So any line that's going to be parallel to that must have a slope of what?
2/3.
The same thing, right? 2/3. How about any line that's perpendicular to this down here then? What would that have to have a slope?
-3/2.
-3/2. Positive becomes a negative. Numerator, denominator, switch. There you are. Guys, there's a ton of stuff in this section. Okay? I guess the main question I'd like to ask is how many are at least with me on this?
I am.
Do you guys get that you cannot proceed until you have y alone? Very important that y is what? Alone. Okay, very important that y is alone. You have to have that first. Then identify slope, identify intercept. We've practiced a lot of getting back into function form. Hopefully that's kind of renewed back into your head and how to do that. Guys, I made a mistake on the quick quiz. The quick quiz is actually on the last page, so don't peel that off here. I think what we'll do is this. I want you to finish that, bring that up to me, I'll grade it, and then I'll just let you take your notes right back with you. However, that being said, I do need to add a few problems to the assignment. So, listen carefully on this. I believe the other day I assigned page 415, is that correct?
Yes.
And you guys tell me if these numbers are right or not. I think I assigned 1, 4, 5, 10, 11, 12, 14, and 17, is that correct?
Yeah.
Okay, I want you to do number 22. I want you to do number 25. And I want you to do number 28. 22, 25, and 28. That's it. Add that to that assignment, 22, 25, 28. I think you were looking at Thursday as the due date. So that being said, how about questions on any of the previous problems I assigned yesterday?
I did on this morning.
How many of you guys got started on it? I guess that's maybe a better question to start with. We're going to get some time in class to work on this quite a bit tomorrow, okay? So do your best to have this done for tomorrow. Be prepared for what it is that we're going to explore. Try and get that quick quiz done for me. Are you peeling it off or not?
No.
No, bring it to me and I'll grade that right away, okay? Any questions at this point?
No.
Mrs. Miller, anything I failed to communicate with them at all? Pretty good? Okay. All right. You guys have that time if you want to work with a partner on this and talk through stuff. Don't just copy, but talk intelligently like you have been all year, all right? Where did I set my pointer down? Did anybody see where I set that? There it is. All right, good work today, kids. Good job.